Well, in the previous video, we saw how to create a basic space using the commands of OpenStudio. Let's go to talk a little more about the space and surface and some things that we could do to make even easier the creation of a space using the OpenStudio package of Python. We're going to start thinking a little more about the surface and the properties that we can change using this command and making some methods of Python that is going to be easier our work by modeling the spaces on OpenStudio. First, we're gonna create some functions and we're gonna save it in a Python class. We're gonna call it a OpenStudio toolbox. And this method is going to be named create space from floor. Remember that we have to create the point3d using the OpenStudio point3d class. So in this method, we're going to use only a list with our points. We're gonna define the height and the model where we're going to save our space, and it's going to return our space. So we're gonna create a list where we're going to save our points, and for every point of our list we're gonna add a point3d of OpenStudio to our floor list. In the previous session, to create the OpenStudio point3d, we use OpenStudio utilities geometry, but we could use OpenStudio.point3d to create the same points. And this method is going to return our space created by extrusion. And to obtain the space, we use the function get. Now, if we open Python and we import our method, I can create a list easily with all my coordinates, our shoebox of 3 meters by 3 meters by 3 meters. Let's create our model. And we're gonna use our method to save the new space, my floor, 3 meters, and save it in OSA. But now it's important to save our space as an object to modify it later. So we're gonna say space 0 is equals to this function. Sorry, here was OpenStudio, I made a mistake. Now let's go to save it. Now we're going to save it as our model.osm true to our right. And if we open this file in the OpenStudio application, we have again our shoebox, but with just a method. Now let's go to focus on the surface. You're gonna see that all the surface and name it like surface 1, surface 2, surface 3, and to know which is the surface type of each surface in our space, we have to use for surface in space 0 dot surfaces, and we're gonna to print our surface name, surface dot name. Excuse me, I forgot the parentheses. There you go. Ready. But what kind of surface type is one of the surface? As we mentioned, the name doesn't help a lot. There's another command that you could use to know the surface type, and it's written just like that, surface type. Now this could be some tedious to write every time that we are creating an space, so let's going to modify our method to name also our surface in a easy way. And we're gonna use another flag that's going to be a space name. It is a string. And after we create our space, we're not going to return it, but we're going to save it. Space is equal to OpenStudio space blueprint height get. Now let's going to say that if our space name length is greater than 0, we're going to modify our name using the command setName and use a space name. And now we're going to use an int named index wall starting by 0 to numerate each surface of wall. Well, we could use a for command to obtain the surface of our space, and if the surface is equal to wall, we're going to use this name for the surface, space name plus underscore plus surface type lower, to use lowercase, plus the string for our index wall. So if it's a wall, we're going to use space name, wall 0, wall 1, wall 2, wall 3. So our index wall has to increase. Else, our surface set name is just going to be a space name plus underscore plus surface type dot lower. We're going to return our space. To make it work, we have to let a space name as last argument, and we're gonna to make a length of 0 as default. I'm going to add here a space name equals space dot name string. That is the command to call the string of our space name. And now is named correctly, so we have the space and the surface type in the name of our space. So this method is going to be easy, our way to modify a specific surface easily. For example, we could call our surface by using surface 1 equals osm dot get surface by name, and we can use space 1 floor and use the command get to obtain our object print surface 1. Now, how could modify sun exposure, wind exposure, or our outside boundary condition? If you use surface 1 dot valid, and for example, we could use valid sun exposure values. This is the true string that you could use to modify this property. And to modify it, we could use surface 1 dot set sun exposure and use, for example, sun expose. Well, this is a floor, so normally this is going to be a no sun surface, but let's going to name another one surface. Let's going to use surface 2 equals to OSM get surface by name, and we're going to name space 1 wall 0 dot get, and surface 2 dot set sun exposure as no zone. So if we print surface 2, we're going to realize that now is changed as no zone. We could use this for wind also. You could use surface 2 dot valid wind exposure values, and this is the string that you could use. We also could change the boundary conditions, valid outside boundary condition values, and you could see every one that we can use in our surface. For example, adiabatic, we can use surface 2 dot set outside boundary condition and use adiabatic. So if we print surface 2, now you're going to see adiabatic here in outside boundary condition. So let's going to save our model again. And if we open in our application our geometry, we're going to see the name correctly of each one of our surface. And if we use boundary condition, we saw a surface adiabatic here in our wall 0. So that's all for this video.